Good morning, friends. Today, let's talk about KMS asymmetric encryption. KMS is one of my favorite security products in the AWS product lineup, just because it's extremely powerful, and it allows you to do some cryptographic operations with unbelievable simplicity. It's FIPS level 2 certified, so it's really a secure product. And I also think that this is very less used by users who are migrating from on-premises into cloud, and also people who are getting started on the cloud computing. So today I thought instead of writing a blog about it, I thought I could speak about it. And also today let's talk a little bit about asymmetric encryption. I think even teams who have been using KMS quite a bit, they have used symmetric encryption, because that's what KMS really does well. It allows you to create AWS default keys, customer managed key. So you can also bring in your own key, which means that you provide the cryptographic material and AWS does the lifecycle management for it. Like you could rotate keys manually, or you can set the rotation to yearly. If you just go with the AWS managed key, then it will rotate it automatically every 3 years. So it's got some really powerful capability. But recently, I think sometime back, I don't know exactly how long ago, KMS introduced asymmetric public key cryptography in the KMS. So I think the more I wanted to learn about it, there's very less documentation available, and even less any technical article about it. So it makes it a little bit challenging for teams to use it, but it's actually a fantastic product. So I thought today I will take a little bit time and give you a demonstration about what the capabilities are and how do you really use it in the real world. So I think before we jump into the demo, let's just quickly go into agenda, right? So let's just talk a little bit about what is KMS. We talked a little bit about what is KMS, but I'm going to use in this demo OpenSSL, and the concept is about asymmetric cryptography. So, and also why this matters. Why is this important? Once you covered the absolute basics, we will then talk about how we can use OpenSSL and the KMS asymmetric key to encrypt some sensitive information on the client side, and then we'll see how we can use AWS to decrypt using the KMS to retrieve the contents in a secure way on the AWS side. So this is my agenda. So let's just talk a little bit about that. So we talked about KMS, right? So basically, KMS is a managed service product offering by AWS. It allows you to easily create and control cryptographic keys that you can use for cryptographic operations. It provides a highly available key generation, key storage, key management, key auditing solution for you to encrypt or digitally sign data within your own applications. Or you can also control the encryption of data across AWS services. I'll not go into a lot of detail because there's a lot of documentation available if you wanted to just get the absolute basics. Because in this video, I'm just going to assume that you are familiar with a little bit about cryptography and some of the products that typically developers and teams use to achieve the encryption. OpenSSL, I don't think it needs a lot of introduction, but I think just for the sake of completeness, it's a commercial grade, full-featured toolkit. Basically, it's for transport layer security and secure sockets layer protocols. It's basically, you can also use it for any general purpose cryptography. It has some libraries that you can use to achieve cryptographic operations, and that's what we're going to use. Especially, I will focus on the public key utility. It's called pkutl command. So this will be used to perform public key cryptographic operations based on any encryption algorithm that you provide. So we covered KMS and we covered OpenSSL, and let's just talk a little bit about asymmetric encryption, right? So asymmetric cryptography or public key cryptography is a cryptographic system that uses key pairs. So you have a public key and you have the private key. Now the public keys, it can be distributed widely, so you can give it to anybody. So whenever you open browser, you go to Gmail or YouTube or Facebook, the server sends the client a public key using the SSL certificate, and once the browser is it could be Chrome or Safari or Edge, it's able to validate that the certificate is coming from a valid source, then you could use a private public key to encrypt the information that you're sending across the wire over to the internet, and the server has a private key which it uses to decrypt this information, right? And it all happens under the hood. It happens extremely fast, but yeah, basically that's it. So SSL or TLS is widely used for achieving data in transit encryption, right? But you could also use this principle to achieve data at rest encryption, right? So this is what we're going to do today. So we're going to take the concept of asymmetric cryptography, and we are going to encrypt some really sensitive information on the client side, and then we are going to send it over the wire. And from the server side, we are going to decrypt it and retrieve the contents back in the original form. So if you're wondering why do we bother, if SSL or TLS is already providing this capability with the certificate, so why do we even need to encrypt it? Because sometimes you need to be absolutely sure, and it's part of security in depth. So you need to be very sure that this information that you're sending over the wire, that even in the event of certificate being expired or compromised, or if there's a man-in-the-middle attack, your information is very sensitive, that you don't want any eavesdropping or anybody looking into it. So there could be times, or there could be use cases where you need to be absolutely sure that the information that you're sending is very secure, and only authorized people are able to look at it and interpret it. So this is why this matters. So okay, so let's quickly jump into the demo. So for the demo, I'm going to be using a few things, right? First, I'm going to be using the console. I'm going to be using the AWS command line interface. Then I'm going to be using the OpenSSL framework, specifically the public key utility commands. And I'm going to be demonstrating this capability to quickly show you how we can do some amazing cryptography using KMS and OpenSSL. Before we get started with the demo, there are a couple of things that we should take care on the AWS side. So even though I'm tempted to do it using the command line interface, I thought it would be good if I could visually demonstrate this capability. So don't worry, if you try to use these keys or the IAM user, by the time you watch this, these accounts would be completely deleted and wiped out. So I'm not really too worried about exposing these keys to you. So let's create a new cryptographic key. So we'll choose asymmetric key. We will use it for encryption and decryption, and we will choose the RSA 2048 spec. We will provide a alias name for this. So let's call this KMS Asymmetric key pair to perform public key cryptography. So as a best practice, I always encourage teams to use tagging, but for this demo, we will skip it. So key administrator. So one of the really cool things about KMS is that it allows you to separate the roles. So you can have a person who is administering the key, who has nothing to do with the cryptographic operations, and you can specify the person or the role who will actually perform the cryptographic operations. So think about, in an organization where you have SecOps or DevOps, and they are really provisioning the keys, and then your teams are the ones, or your application services are the ones who are doing the cryptographic operations. So it makes the separation of concerns between managing and using the keys. So this is something that's really cool. So I'm gonna just go next. And so in the next step, we will create a new user. But for now, we will just leave this as just that I'm the only person who can both administer the key and use the key. So let's just go ahead. And if you just scroll, this is a key policy. Basically, this is just echoing what we set on the console. It says that this IAM user has the access to administer the key. There's a set of cryptographic operations, and who can use the key and who can administer the key. So we're just going to go ahead and click finish, and voila. So we have our key that we will be using in this demonstration, right? So one of the things that we need to do is first we need to go, and you can see this is the public key. So you can either manually copy it or you could just download it. So I'm just going to go ahead and download. As you can see, it creates a .pem file. So we will be using this public key to encrypt information, encrypt the sensitive file on the client side, and then we were going to see how KMS can decrypt it from the server side. So now let's just go and create a new user. So I already opened this console, so I'm just gonna switch back and say, okay, so I will allow decrypt operation. So when you create an IAM user, IAM role, keep in mind that you don't want to give more privileges than what is absolutely needed. So in this case, I'm going to go and get the key ARN, and I'm going to say that this user will be allowed to only perform decrypt operation on a very specific resource, which is the key that I just copied. So add. So what I just did is that I created a policy called KMS Asymmetric Crypto Policy, and go ahead and create the policy. We'll go ahead and refresh, and now it shows up. We'll go ahead and once again, tags are very good practice, but I'm just going to skip it. So what I did is that I created a new user called crypto user. This user has only programmatic access, and it allows, so far the user is only allowed to perform decryption using KMS with that specific key that we just created right now. So voila. So what we just did right now is we are just setting the stage for the demo. So we created a IAM user, and then we created a asymmetric key. So let's just pause and then see how we could use this information to continue the demo. Okay, so now what we will do is we will have to configure this user that we just created so that we could enable programmatic access from the console. So I'm going to assume that I'm not going to show the steps to install the CLI capability in the Windows. So it's just a binary executable that you download and get it set up. So the command to do that, to configure the new user, is AWS configure. It takes a while because of the bandwidth. So we have to copy this access key ID, and we have to copy the share secret access key. Once again, I'm not too worried about showing this. It is sensitive, but I'm just going to delete this after we are done. So the region would be AP South 1, and the default output format is JSON. So that's it. So we just configured. So how does it really work? I'll just show you how it works. Hey, so just to show you guys that, about the access, because this is something really important, right? So if I try to do a list buckets command using the profile that I just configured for this session, you're going to see that after a while, it's going to just check whether I have the role that I've logged into has access, and it's going to report an access denied error because my role doesn't allow me to do anything other than a decrypt operation. So while this is coming, I think there is some, as you can see here, I get an access denied because I do not have permissions to perform list buckets. So I wanted to show you something really cool, right? So if you have Git installed, and I don't see why you wouldn't. Any developer would have Git installed in their system. So you don't need to Git clone and install and build and install the OpenSSL. You can actually just navigate to system32. If you can navigate directly to the Git folder under user bin, and as you can see here, you have OpenSSL already available. So you can perform cryptographic operations using OpenSSL without having to go through all this trouble of cloning the code and building it and installing the binaries. So just a little bit of a trick that I learned. So let's go ahead and run the command on this site. So let's go ahead and clear the screen. So what I'm going to do is I'm going to take this key and I'm going to take this file and I'm going to generate an encrypted file, right? So the command that I will enter is OpenSSL private key util encrypt. Use the public and use this key. So let's go ahead and we need the full path. So let's go ahead and get that. Paste it. Public key.pem. So by default, OpenSSL private key public utility looks for .pem file. So only if you want to use a different format, then you have to specify. But otherwise, it works with default .pem. So you don't need to explicitly specify that. So, and we kind of have to provide an in file. So let's go ahead and copy the same. And we will say it's going to be my super secret file.txt. And we will provide an out file. We'll provide the same path. And we will say my super secret encrypted.enc. And this is important. So we have to provide a optional parameter without which this encryption will fail. OpenSSL will still go ahead and encrypt it, but KMS will not be able to decrypt it because you have not really specified the algorithm. And by default, if you don't specify the algorithm, it's going to use the SHA-1. So I like SHA-256 because it's much more stronger. So if you want to do that, you need to provide an optional key parameter, and this is a command to do it. So you have to say RSA padding mode OAEP P key optional RSA. I happen to work here. It's a fantastic company. OAEP MD SHA 256. So what have I done here? So just look at the command, right? So I'm calling the OpenSSL, I'm evoking this utility, I'm telling it to encrypt it using this public key, and I'm providing the path, the absolute path of my key file. I'm providing the file that I want to encrypt, and I'm specifying the file that I want this utility to output. I'm providing the key parameters. I'm specifying which algorithm to use. So let's see what it does. So there you go. So as you can see here, it just performed encryption. So if you're curious what's in there, it's just random stuff. So what we have done now is we have achieved encryption using the public key that we downloaded from KMS, and we use OpenSSL to perform the encryption. So let's just go to the next step where we will. So at this point, what we're going to do is we're going to assume that you open a connection to API, which is in the AWS side, and you're sending this information securely with SSL enabled, so that AWS receives it. So I'm not going to go much into details about SSL termination, how you're handling internally, in-transit encryption, because I'm just going to assume that all that infrastructure is in place. So here I just want to exclusively focus on, encryption at rest. So we'll now go to the next step where we will see how AWS is able to decrypt it with the public key, with the private key, using the credentials of the user that we just created. So before we get started with the decryption operation, I wanted to tell you guys that when you do an encrypt operation, in this demo, I showed you how to use OpenSSL. But if you're operating only within the AWS cloud environment, you can optionally use the AWS KMS encrypt operation instead of using OpenSSL. And when you do it, just keep in mind that when you provide the key ID, and I'll show you what this means. When you provide the key ID, KMS automatically uses the public key to encrypt this, right? So because this is different from how symmetric keys behave, so I wanted to just highlight it that when you use the AWS KMS command to encrypt any content, and you're working within the AWS itself, or you're using applications that are working dedicated from on-premise to AWS, then you may say, why do I even need to bother about OpenSSL? And you are right. So you can use the SDK that AWS provides and pretty much directly call the AWS KMS encrypt. In that case, you need the key ID, and you need to, then KMS will automatically use the public key to do the encryption on behalf of you. So I just wanted to tell you. But in this demo, we are just going to do it in a disconnected way, where you're using OpenSSL to do the public key encryption, and you're going to use KMS to do the private key encryption. So now that we have our super secret encrypted file that we saw, now let's see how we could use KMS to decrypt it, right? So keep in mind that I'm still logged in as the console user, as a programmatic user with only access to do the decrypt. So I'm just going to type in the command. You could do it in, in your favorite language, C#, Java, or Python. But I'm just going to use CLI because I already have everything configured, and it's much easier if I explain this with CLI than if I just compile and run a bunch of Python code. So the command is AWS KMS decrypt. We're going to have to punch in the key ID. So instead of key ID, we could use alias. If you remember, we created an alias. This is the name of the alias. And we will say the encryption algorithm. This is really important because if you don't get this part right, you will have a invalid client exception. It took me a while to figure out, and there is very little documentation available, so you need to be very careful with this step. So the concept is that whatever algorithm that you use to encrypt with OpenSSL needs to match the encryption algorithm that you're explicitly telling KMS in this step, because by default OpenSSL uses SHA-1, which you can't, then it creates an impedance mismatch. So you may want to be explicit in telling which encryption algorithm you want to use in both the public key side and the private key side. So I'm just going to say my encryption algorithm is RSA ES OAEP SHA 256, and my ciphertext blob is going to be a file on this absolute path. Let's just go ahead and copy this path and we'll paste it here, and we will provide the file name, which is my super secret encrypted.enc. You want to be careful with your spelling, otherwise it will not work. And you want this output in text form. So you want to specify the query parameter. You want this in plain text, and you want to cat this in the same folder, and you want to provide my decrypted file dot base 64, because KMS, when it performs the decryption, it returns to you in base 64 format, and you need to decode it, and I'll show you the next step. So I think we got all this command punched in right, so let's see what happens. All right, so just to go over this command, so we are telling AWS, use the KMS service, do a decrypt operation, you're providing a key ID. So KMS has this really cool feature where you don't need to specify the key ID. Instead, you could create aliases, so you can have multiple aliases. So this could be useful when if you want to just create something that you want to use with a common name instead of having a really long key IDs. So you could create, and so in this case, if you remember when we created the asymmetric key, we provided this alias called KMS Asymmetric KP, and we are telling this, use this encryption algorithm, which should match the algorithm that you use to perform the encryption at using OpenSSL. Then you're telling the ciphertext blob, you're providing the absolute path of this encrypted file, and you want this output in a base 64 format with this file name, my decrypted file. So, and you're providing the region where you are performing. Just mind you that KMS is regional service, which means that if you create a key in one region, it cannot be accessed in another region. So, something to keep in mind. So let's see what happens when we execute this command. Okay, so that's good. It created a file, but it's still executing in the background. Let's just give it a second. Okay, it's done now. So we have our decrypted file. Let's just go ahead and open this. So we have some base 64 encrypted file. So we have now achieved decryption using KMS. So the next step is we want to do decoding, because if you use if you try to open this file directly, you will not be able to send, because it's in base 64 format. We have one more step left in this demo. So we have successfully decrypted the file from KMS using the key ID and the algorithm. So now we have to convert this decrypted text into text format, because KMS returns in base 64 format. So let's go ahead and type in the command OpenSSL base 64 decode in file, provide the path, my decrypted file dot base 64 out file, same path. We will say my super secret file decrypted.txt. And there you go. So we have our super secret file decrypted. Let's go ahead and open and see. Oh, there you go. So my super sensitive data that no one should be able to read. And if you open this one, they are identical. So let's go ahead and summarize what we have really done here, right? So we used KMS. We created a KMS public key pair. We downloaded the public key. We used OpenSSL to do an encryption of a sensitive file, and then we sent it over to AWS, or we built on that assumption, and then we used KMS to do decryption using the private key, and we were able to decode that in text format, and we were able to retrieve the file content. So I hope this has been very helpful for the viewers. So with literally 3 or 4 lines of code or command, you are able to do some really powerful cryptography. So I hope you would use this in your projects or encourage your teams to use it. Because KMS is a very powerful product, and it allows, and with the asymmetric encryption, you can do some really cool things. So thanks for watching, and drop me a word if you have any questions, or if you want to improve this content, and I'll be very happy to hear you. Thanks so much for watching, and have a great day.